Alright guys, so this pump showed up at our shop and the customer said they want us to go through the motor, go through the pump, and repair it. And we can see that here on our fancy little green sheet, rebuild pump and motor, go through. The first thing we're going to want to do is open up that pecker head, and I'm going to grab a little flat blade screwdriver out of here so I can pull those screws out, and then we're going to do a megohm test on this, which essentially is going to be testing our insulation resistance to ground. We want to make sure the winding isn't shorted to ground. It could also be extremely dirty, which is why sometimes people will refer to a meg test as a dirt test. If you get a bunch of water or contaminants inside of the winding, it's going to pass voltage through to the frame and you're going to get a bad reading. So we have our red probe going to one of the line leads of the electric motor, and then we have our black ground going to the frame of the electric motor. Now you don't really need to switch between these leads and check it again, but I just want to make sure that there's not an open in the winding that's giving me that quick 550 reading. After we take those nuts off the impeller housing and cut through all of this silicone sealant that's on here, we can pull this off and expose our impeller. Now this should be an enclosed impeller, meaning we should not see those veins. You can see that this thing is in extremely bad shape. It looks like there's also some signs of cavitation inside the volute housing where we have material missing from these tiny little supersonic explosions. This looks like a pretty nasty scenario of erosion, cavitation, and dezinkification. Now once we remove this worthless impeller, we can give it another once over, and you can see that there's actually holes completely through this impeller. I don't know if those holes were completely worn through. Sometimes these impellers do have little holes to kind of offset the pressure and relieve some of the thrust or the axial thrust against the bearings. Now there's a fancy gadget hidden right behind this impeller, and that's going to be our mechanical seal, this little guy on the shaft right here. This is what's going to keep any of our pumping liquid from exiting the pump. So we have that ceramic seal down in the bottom and this carbon seal. This is our rotating seal that's in my hand, and our stationary seal is the ceramic seal at the bottom. And if we plan on getting any replacement parts for this thing, we're going to need to clean this label off and make it legible. In the meantime, let's run this motor. Now I know what you're thinking at this point, just throw it in the trash and get a new one. It seems like everybody in society today just wants to throw things in the garbage and get a new one, order a new one on Amazon. You can get it next day if you're a Prime member. Are these little rubber flinger slingers sitting on the shaft here? These things should be pliable. They shouldn't be this brittle. This is just from excessive heat over time. We can pull these through bolts out of this electric motor. We'll pull these end bells off. We'll measure these end bell housings where the bearings fit. We'll make sure that those are within tolerance of the manufacturer's spec for the bearing. And just letting this tag sit inside our organic parts washer for a little bit, it cleaned it up enough that it was legible, but the light really wasn't bright enough in the shop, so I took it outside where you could hear the birds sing, and I was able to find out that this is a stay right pump. Cheers, guys.